In this session, we'll talk about several terms that relate to classification of matter. Matter can be classified into several categories depending on its composition and what it looks like. Matter can be classified into pure substances or mixture. A pure substance is a substance that is only made up of one thing. For example, water. Water is a pure substance. For example, salt. For example, sugar. For example, oxygen, gas that we breathe in, so on and so forth. So I gave the examples of water, H2. I'm sure you're all familiar with this notation of writing water. How about salt is also sugar. Oxygen gas that we breathe in is also pure substance. There are several examples out there. These are not the only ones. Mixtures, on the other hand, are physical combinations of two or more pure substances, and this is an important part to remember, that it's a physical combination. So let me explain, what does the physical combination mean? Matter can combine with each other. One substance can combine with another substance in two different ways, either in a physical combination or a chemical combination. A physical combination is just a mixing of two substances. When you take salt and sand and mix them up really nicely with each other, that's a physical combination, because the sand particle and the salt particle, they retain their characteristics. They retain their chemical identity. Salt and sand are still salt and sand. They have not become something else. A chemical combination, on the other hand, is a combination of two or more things that then chemically make something different that didn't exist before. For example, if you were to take hydrogen and oxygen gas and apply some current to that mixture, suddenly they will combine with each other chemically and make water. So that's a chemical combination. Mixtures are created when two or more pure substances combine with each other only physically. Pure substances, on the other hand, are created when chemical combinations take place. Pure substances have a definite and constant composition, whereas mixtures can have variable composition. Now, what does that mean? It means that no matter where water is present, no matter in which physical state water is present, water must have the same proportion of the two substances, hydrogen and oxygen, that are making it. In other words, water must have 2 parts hydrogen combining with 1 part oxygen. Only then will it be water. Let's say hydrogen and oxygen instead combined with each other not in 2:1 ratio by mass. Instead, it combined in 1:1 ratio, H2, 2 parts of hydrogen combined with 2 parts of oxygen. Is that water? The answer is no, that's not water. Hopefully you will not sit with a glass full of H2O2 at dinner time. Instead have H2O, because H2O2 is hydrogen peroxide, a completely different substance with completely different properties that has nothing in common with H2O except the fact that it's the two same substances, hydrogen and oxygen, that are making it. Similarly, when you breathe in oxygen, that gas has to be made up of exactly the same thing, no matter where this oxygen gas is present. But when you look at a mixture can have variable composition. It may be 1 tablespoon of, let's say, sugar in a gallon of water. That's a physical combination. That's a mixture, as opposed to 5 tablespoons of sugar in a gallon of water or 20 tablespoons of sugar in a gallon of water. In each of the 3 cases, they are the same mixtures but different compositions. Now, what happens as you change the amount of sugar in the water when you make that mixture? The property of that mixture changes. So yes, properties of mixtures will change as the composition changes. That's not the case with pure substances. Pure substances will have the same properties because they have the same composition. They must have the same composition. Another very important point to remember about mixtures is that the components of a mixture can be separated by using a physical process. For example, taking the example of sugar and water mixture. If I gave you the task of separating the sugar and the water from each other, what would you do? Exactly. You would distill out the water. You would evaporate the water, collect the vapors, and condense those vapors back into liquid. That way you will have sugar left behind as solid, as a white solid tasting sweet as it's supposed to, and liquid water separate from the sugar. So physical processes help us separate components from a mixture. But what if I asked you to separate the components of water from each other? Can we do so? Yes, we can, although we cannot do so through physical processes. What we need to do that are chemical processes. So another point to maybe note down is that the components of a pure substance can be separated, but not through physical means, but by chemical means alone, chemical processes. Okay, so that's the difference. Those are the differences between pure substances and mixture. It may be a good idea to pause the recording at this point and maybe make a list of some pure substances that you can see around you, and some mixtures that you can see around you as well. I'm sure you'll come up with many. Okay, so pure substance can further be classified into either being elements or compounds. So let's understand the difference between the two. Elements are the basic building blocks of all types of matter. Elements cannot be broken down, and something that is very important for you to remember and understand, they cannot be broken down into simpler substances by any means, no matter what. Although I would ask you to, at this point, insert a word in this sentence. They cannot be broken down into simpler, stable substances. Yes, it is possible to break down elements into smaller pieces, but those smaller pieces are not stable enough to exist on their own. So you cannot break down an element into simpler, stable components based using any kind of means. Compounds, on the other hand, and please note the difference, compounds are created by a chemical combination of two or more elements. Now, this definition of compounds, that it is a something that you get through a chemical combination of two or more elements, this definition is very important for you to understand and remember. We will come back to this definition later on in the course as well, but please focus on each and every word in that definition. Can we decompose a compound into its components? Can we decompose water into hydrogen and oxygen? Absolutely. Sugar is a compound. Sugar that you eat on an everyday basis is made up of carbon element, C12, hydrogen element, and oxygen element in this proportion by mass. 12 parts carbon, 20 parts hydrogen, 11 parts oxygen makes sucrose, which is the sugar that we eat. It's a compound. It's a chemical combination of those three elements. Can we break it down? Can we decompose this into carbon, hydrogen, and oxygen? Yes, we can. But how? Only through chemical methods. So you need a chemical process to decompose or to separate the components of a compound. Compounds must have, and it is very important once again to remember, must have a definite and constant elemental composition by mass. In order for sucrose to be sucrose, the ratio of CH and O has to be C12H22O11. What if you change that ratio? What if the ratio in which carbon were combining chemically with hydrogen and oxygen were different? It was, let's say C2H C2H6O. Will it be sucrose anymore? No, C2H6O is not sucrose. C2H6O has very different properties than C12H22O11 does. Can you add a spoon of C12H22O11 in your coffee, morning coffee? Probably you can, because it's sugar, it's sucrose. Yes, but can you add a teaspoon of C2H6O in your morning coffee? You probably still can, but not for the same purpose. You see, C2H6O, the one that I have in mind, is not sugar, it is alcohol. Can you add it in your coffee? Probably. But will it make your coffee sweet? No, it will not. It won't serve the same purpose. C2H6O is a completely different substance with different properties than sucrose, even though the elements are the same. So very important that for a compound to be a compound, the elements must combine in a definite and constant proportion by mass. Okay. Just as pure substances can be classified into two categories, mixtures can also be classified into two categories. Mixtures can either be heterogeneous or homogeneous mixtures. A heterogeneous mixture is one in which you can visibly see the components that make the mixture. Whereas in homogeneous mixture, the components of the mixture are not visible. We use the word phase here to describe the layers that are, or the components that are making up that mixture. For example, let's think of one. How about sand and water? When you mix sand and water, do you get a mixture? Yes, you do, because that's a physical combination. But do you get a homogeneous mixture or a heterogeneous mixture? Can you see sand phase separate from water phase? Yes. So that would be a heterogeneous mixture. Let's, instead of mixing with sand, let's mix water this time with salt and stir it up. Do you get a mixture? Yes, you do, because once again, salt and water do not chemically combine with each other. It's a physical combination. But can you visibly see the salt phase? No, you can't. So when the components that you mix with each other, physically mix with each other, become visibly indistinguishable, that is a homogeneous mixture. Each phase in a heterogeneous mixture, each layer in a heterogeneous mixture have different properties. So sand has different properties than water. But in a homogeneous mixture, the entire mixture has the same properties. So the entire mixture, salt-water mixture, no matter where you get a few drops from in order to taste, will taste the same, because the properties of the two substances have also been homogeneously, uniformly mixed throughout the mixture. So heterogeneous mixture is a non-uniform mixture where the components are visibly separate from each other. A homogeneous mixture, on the other hand, is a uniform mixture where the components cannot be visibly separated from each other. Here is a pictorial depiction of the different classifications of matter, and I hope you can see the differences that we just discussed. When you look at an element, each individual particle is exactly the same as the other particles. That's the same for compounds as well. If you look, individual particles of the compound are exactly the same as the next particle of the compound. Right there, they're made up of the same substances in the same way, same order, same shape, everything's the same. But the difference between the element and compound is, if you notice very carefully, the individual particle is just one particle, whereas in a compound, the individual particle is made up of several smaller particles. As you can see, they could be either the same or different, but they are different particles, different elements, in other words, combining with each other chemically. When you compare the pure substances to mixtures, I hope you can see that in mixtures there are different kinds of individual particles. Whether it's oil and water, that's a heterogeneous mixture where the oil particles sit on top of the water particles because oil has lower density than water. But in a homogeneous mixture, on the other hand, you can still see different kinds of particles. Here is one kind of particle, here's another kind of particle, here's a third kind of particle, and then there is another big kind of particle right there. They're all different from each other, but they are uniformly mixed with each other. So just by looking at that sample, you cannot tell where each of those particles is. That's a homogeneous mixture. Okay, so let's let's just summarize some very important and fundamental differences between compounds and mixtures. Compounds are pure substances that are created by a chemical combination of two or more elements, whereas mixtures are created by physical combinations of two or more pure substances. Compounds must have a constant and definite proportion by mass of the combining elements. If you change that proportion, it's a completely different compound. Mixtures, on the other hand, can have different compositions of the components that are mixing together. Compounds, components of a compound or elements that make up a compound can be separated from each other. In other words, a compound can be decomposed into its elements, but only by a chemical process. Whereas the components of a mixture can be separated from each other by a physical process. So these are very important differences between the two categories, which will help you categorize matter in either one of those. So let's try out a few examples and decide whether each of these substances should be classified as a element or compound or homogeneous mixture or a heterogeneous mixture. You might want to pause the recording at this time to write out your own answers before we check the answers. Okay, so here are the classifications that each of those substances will fall under. Tap water is a mixture. Tap water is not pure water. There are lots of substances mixed there, but visibly those substances are not distinguishable. So that's a homogeneous mixture. Sugar, the sugar that we eat, is a compound. It is made up of more than one element, but through a chemical combination of those elements. Soda, now this is a little bit tricky. You have to be careful. Now if it's freshly opened soda, as soon as you open the can or the bottle and you see bubbles, you see the fizz, that's a heterogeneous mixture because you're able to visibly see the gas separate from the liquid. But if it is flat, the gas has all escaped already, then that is a homogeneous mixture because the rest of the components are visibly indistinguishable. Air on a clear day is a homogeneous mixture. Air is made up of many gases, but on a foggy day, the water vapor is separate from the rest of the air, so that's a heterogeneous mixture. Ice is a compound. Ice is nothing but water frozen. So that's a compound. Oil and water, heterogeneous mixture because oil sits as a separate layer, a separate phase. Table salt, if it is just salt, it is a compound. It is a compound that is made from a chemical combination of sodium and chlorine. But if it is iodized salt, then that is a homogeneous mixture. So unless we say iodized salt, you should assume a compound. And if it is iodized, then of course it's a mixture, homogeneous mixture. Rust is a compound. Rust is a compound that is created between iron and oxygen. Iron oxide is rust, and that's a compound. Sterling silver. Sterling silver falls in a category of substances with bronze and steel. These are all collectively called metal alloys. Metal alloys or alloys are homogeneous mixtures of two or more metals. So no matter which metal alloy you talk about, that's a homogeneous mixture. Tea, of course, we're assuming it's just the tea, it's just the liquid that we drink, and that's a homogeneous mixture, unless you're drinking a cup of tea that you can actually see the tea leaves floating around or something else, then that would then make it heterogeneous. So when we are classifying these different things into the different categories of matter, it is very important to know, first of all, what's present in there. First of all, to know what is the composition of these substances, and then also to know what does it look like. Ice and water. If you have a glass of water with some ice in it, now how would you categorize that? Is it a mixture? It is a compound. That's a very interesting situation, because if you look at it, this sample is chemically homogeneous because the chemical identity of ice and liquid water is exactly the same for both of them, right? But physically they are in different phases. So physically that's a heterogeneous system. So that's a very interesting case where you kind of have to be a little bit more creative in your definition and call it chemically homogeneous but physically heterogeneous.